Recent discoveries made by the James Webb Space Telescope have left scientists astounded, revealing phenomena in the early universe that challenge our current understanding and theoretical frameworks. Among these discoveries is compelling evidence suggesting that events may have occurred before the Big Bang. Renowned physicist and Nobel Prize winner Dr. Roger Penrose has described these new findings as overwhelming, indicating that something existed before the inception of our universe. The evidence uncovered by the telescope poses significant challenges for conventional cosmology, as it implies the occurrence of an event before the Big Bang. In this discussion, we will explore notable discoveries, including a black hole potentially linked to a former universe, the existence of extraordinarily large structures that defy our cosmological models, and a galaxy that emerged just 90 million years after the Big Bang. These observations raise the possibility that the Big Bang may not have been the definitive beginning of the universe. It's essential to note that the universe might not have a clear start or end. Instead, it could exist in a continuous cycle of creation and rebirth. Common misinterpretations of the Big Bang suggest a singular point in time where all matter, energy, space, and time were compressed into a unified state. However, this state did not exist within empty space, as there was no space to contain it at that time, making it challenging to visualize. Scientists describe this early universe as an infinitely dense, hot state, but beyond that, constructing a mental image becomes difficult. One might envision the entire universe as a tightly woven fabric where every part overlaps. However, this depiction is misleading as it implies a central point of origin for the universe's expansion, which is incorrect. In reality, the expansion of the universe began everywhere simultaneously, not from a specific location. This leads to an essential question: how can everywhere exist if the universe is just beginning to expand? It's acknowledged that the universe appears to be infinite in scale, meaning it expands within itself rather than into an external space. Since infinity cannot be compressed, when the universe expanded, it was not growing into a larger space, but rather stretching throughout all of existence at once. As space expanded, it created minute disturbances in the quantum fields that permeate the universe. These remarkable insights provide a deeper understanding of the cosmos and challenge our perceptions of its origins. These small fluctuations eventually turned into matter and energy, appearing everywhere across the cosmos at the same time. This is very different from a normal explosion. In an explosion, matter is thrown out from a central point. But here, matter came into existence in a completely different way. Imagine an infinite box where matter suddenly begins forming throughout the entire box at once, not from one single spot. After the first particles formed, it was still too hot for atoms to appear. Gradually, the universe cooled enough for particles to combine into atoms. This process took hundreds of thousands of years. While all this was happening, an invisible side of the universe, sometimes described by scientists as a kind of mirror or parallel universe, was where dark matter existed and was already forming. When normal matter was still trying to form stable atoms, dark matter was already starting to group together. Scientists think that where dark matter clumped in the unseen universe, it created gravitational wells in our universe. These wells pulled normal matter into them, causing it to gather. Gravity was key in the early universe. It pulled matter together, creating clumps in denser areas. In less dense regions, matter spread out because of the stronger forces of expansion. These initial clumps combined to form the first massive stars, which were big and unstable and burned out quickly. As the early stars collapsed, they turned into black holes. Over time, these black holes pulled in surrounding material and gained enough mass to create the first galaxies. However, these early galaxies looked different from the spiral or elliptical galaxies we see today. They were small, irregular, and chaotic. The universe at that time seemed crowded and disordered, unlike the beautiful galaxies we observe now. As billions of years went by, dark matter and gravity kept shaping galaxies. Galaxies often collided and merged, gradually becoming larger and more complex. After nearly 14 billion years, we ended up with the diverse spiral and elliptical galaxies we see in our universe today. Modern telescopes allow us to see galaxies at different stages of development from the past, since the light from these distant galaxies has traveled through space for billions of years. However, due to the universe's expansion, the space through which this light travels is also stretching, causing the photons to lose energy and shift into the infrared spectrum. To capture these ancient photons, infrared instruments such as those on the James Webb Space Telescope are specially designed. Nonetheless, a significant challenge has arisen. The James Webb Space Telescope detected infrared light from galaxies in the early universe that appear more developed than current theories would suggest. According to the standard Big Bang model, these early galaxies should be small, irregular, and forming slowly. Instead, Webb has identified numerous galaxies that exhibit well-defined spiral shapes and significant mass, with some even larger than our own Milky Way. Additionally, many of these early galaxies are forming stars at a pace much faster than modern galaxies. This discrepancy poses a question: how could dark matter and gravity shape such complex galaxies in a relatively early time frame? This has led some scientists to hypothesize that there may be unknown processes or forces that accelerated the formation of these early galaxies. Moreover, surprising findings include galaxies identified by Webb existing at a time when, according to current theories, only the first stars should have been igniting. One notable example is a galaxy designated Capodimonte C, which has a redshift of around 32, indicating it existed just 98 million years after the Big Bang, a period when the standard cosmological model suggests the earliest stars were only beginning to form. Some researchers, including Dr. Roger Penrose, suggest that our universe's story may extend beyond the Big Bang, proposing a predecessor universe that influenced its formation. While robust proof of a previous universe is lacking, recent findings from the James Webb Space Telescope hint at something extraordinary existing before the Big Bang. Current measurements indicate the universe's age since the Big Bang, but my earlier work suggested evidence of an earlier universe. Astronomical observations challenge conventional cosmology, hinting at events preceding the Big Bang. I propose that the Big Bang was not a singular beginning, but a continuation from a previous cosmic eon. Evidence is emerging in the form of a supermassive black hole discovered by the JWST, which appears too massive to have formed solely from first-generation stars. Two theories for its formation have emerged, one suggesting direct gravitational collapse of dense regions, and the other proposing primordial black holes that may have originated in prior universes. Additionally, Dr. Penrose has suggested that traces of an earlier universe could exist in the cosmic microwave background, or CMB, radiation. Recent studies hint that the CMB may carry signals from early galactic formations or unknown phenomena, challenging standard cosmological interpretations. Furthermore, recent observations suggest that the universe's expansion may be slowing, raising the possibility of a future collapse known as the Big Crunch, which could imply that previous universes existed before ours. These discoveries invite scientists to rethink our understanding of cosmology. They are finding huge cosmic structures that are much larger than our current models predict. After the Big Bang, matter was supposed to be spread out evenly, with only small variations. This understanding limits the growth of cosmic structures. However, newly observed structures show regions where matter is concentrated more heavily than expected. In cosmology, we refer to the cosmological principle, which states that, on the largest scales, there should be no noticeable structures or patterns. This principle has a cutoff limit of about 1.2 billion light-years, but the giant arc observed is over 3 billion light-years wide. This raises questions about how such a structure can form. With these surprising discoveries and unexpected early structures, many scientists now believe there are strong hints that something existed before the Big Bang. If we look at a cyclic universe model, we can explain many of these mysteries more easily. This model accounts for the surprisingly mature galaxies seen in the early universe and helps clarify several cosmic puzzles that the standard Big Bang model struggles with. The idea that another universe may have existed before ours is not new. For centuries, scientists and philosophers have discussed whether the cosmos might go through endless cycles of birth, death, and rebirth. Long before modern telescopes or studies of cosmic background radiation, thinkers proposed that the universe might not just have one beginning or ultimate end. Instead, it may pass through infinite stages. A universe comes into existence, expands, ages, collapses into a state of non-manifestation, and then emerges again. These cycles are known as kalpas and pralayas, and the grand cosmic cycles are governed by kala, or time. This resembles the cyclic universe idea found in modern cosmology. Other traditions also mention cosmic cycles. Ancient Greek philosophy talked about equipersis, a periodic destruction and rebirth of the universe. Certain Buddhist cosmologies describe cycles of expansion and contraction of world systems. Across different cultures, over centuries and now seen in scientific research, one powerful idea keeps coming back. Maybe the universe has no single beginning or end, only endless cycles of existence. That's the end of this video. If you found it interesting, please share your thoughts in the comments. We'd love to hear from you. If you'd like to support our work, you can do so by purchasing our t-shirts or donating. Your support helps us create more great content. Thank you for watching.